In high school, I always wondered why we need to take the first derivative of a function and set it equal to 0 to determine the function's maximum. But actually, it is quite intuitive. So consider here a function, a nonlinear function, where the function value depends on the axis on the right-hand side. It's a nonlinear function. We have the term x squared here. And we see, since x squared enters with a minus sign, that first, for a very low value of x, this function will be increasing, and for a very high value of x, the function will be decreasing. So clearly this pattern leads to a situation where we will have a maximum at some point in between for an intermediate value of x. Now, how does this relate to the derivative? Take the derivative of this function, which is 3 minus 2x, the 5 drops out here, and we see that this is a straight line basically that gives us the slope of the nonlinear function at a given point x. Start with a low value of x, then the derivative will be positive. Because x is low, 3 minus 2x will be positive. So at this point with a low value of x, the derivative of the function at this point will have a positive slope. So we will have a positive function here. Now consider a high value of x. Here, by contrast, at this point, this function would be negative. So we would have a negative slope at this point, at this derivative. And now it's clear that somewhere in between, we will have one x for which the slope of the curve at this point is exactly equal to 0, and we get a flat line. Why is this the case? Because at this point, irrespective in which direction you move, you will always go down, so the function value would decrease. So at the point where the derivative is equal to 0, you have achieved the maximum of the function. In other words, the function is at its maximum at exactly the point where in every direction you go downwards. And that is similar, for example, to the case where if you are on the North Pole, then irrespective in which direction you move, you go to the south. So that's the northernmost place you can be on Earth. This simple illustration can be generalized to higher order terms where you would only be able to identify local maxima, to multivariate functions where you would have partial derivatives instead of just the derivative with respect to one variable as we have it here, and of course to minima.